All right, and we're going to wrap up our unit on quadratics with applications of quadratics. So the good news about this particular lesson is that there's nothing new to teach you, all right, mechanics-wise. Now it's all about interpreting, all right, what we've done. So knowing when do I use, all right, my equation to find the vertex. When do I use the quadratic formula? So it's now taking some of the things that we've already talked about, all right, and then interpreting the problem and knowing which part to use. So we're just going to jump right in with this lesson, all right? There's no opener today. We're just going to go right into the word problem. All right, so now notice, okay, the path of the rocket launched from a pedestal is given by the equation h equals negative 16t squared plus 128t plus 3, where h represents the height of the rocket and t represents the time in seconds after the rocket is launched. So that's the situation we have, right? So notice the first question here. How tall was the pedestal the rocket was launched from? Well, if we think about that, that would be the initial, right? That's at the very beginning. And so that would have been when t was equal to 0. All right, and so what that means is now I want to go to my equation and I want to plug in 0 for t, and then I want to just simplify that, all right, to see what I get. Oh, and I put this t there instead of a 0. And notice all of this is going to be 0. All of this will be 0, which leaves me just 3. So what that's telling me is that the rocket was sitting on a pedestal, all right, that was 3 units high, all right? So 3 feet, 3 meters, all right, when it was launched. Okay, now let's think about this. How long is the rocket in the air, right? So if we just think about like a picture here, right? So we know it started at 3 feet, right? It gets launched, it's going to hit a maximum height, and eventually it's going to come back down, all right? And so when it hits the ground, right, now it's no longer in the air. And that tells me, all right, what to plug in. So when the rocket hits the ground, that means h is 0, all right? And so now I plug 0 in, all right, to my equation right here. So how long was the rocket in the air? So I plug 0 in right there. So 0 equals negative 16t squared plus 128t, all right, plus 3. All right, now, so notice, now this goes into, all right, we have to interpret this, okay? So how do I solve this equation, right? We've talked about a few different ways, right? Okay, and typically in a word problem, you're probably going to use the quadratic formula, especially if you look at it and you don't necessarily see a combination, all right, really well. Because a lot of times with these problems, we don't get like exact answers as far as like 3 or 8. It's going to be a decimal a lot of the times. So what we want to do now is just jump right in and use our quadratic formula, all right, to solve this. All right, so if I look, right, A is negative 16, all right, B is 128, and C is 3. All right, so x equals, and remember, you should have the quadratic formula memorized here. So the opposite of b, so negative 128 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, and now we just want to use our calculator and simplify what's inside that square root radical. Let me clear all that out. So we want to do 128 squared minus 4 times negative 16 and then times 3. And so that gives me what's inside my square root radical, plus or minus the square root of that really big number, 16,576, divided by negative 32. All right, now we want to separate this. So x equals negative 128 plus that square root, 16,576, divided by negative 32, and x equals negative 128 minus square root of 16,576 divided by negative 32. All right, and then we just put that into our calculator, right? So negative 128 plus second square root 16576, hit enter, and I'm going to divide that by negative 32. All right, and I get negative 0.02. All right, and then x equals negative 128 minus second square root 16576, which equals that number. Divide that by negative 32. All right, and that gives me 8.02. Now, here's the other piece. Now, those are both solutions, but we're in context now. We're in a real life situation. So now we want to look at our picture, right, and think about which one makes sense, right? Well, one, we don't want to go back in time. So this is a negative value here. All right, so we know that that's really, if I extended this graph, right, that would have been where it would hit back there. But we know it started right here. And so when we look at our picture, it's like, oh, it hits right here. So that tells me that this is the solution I want. So now you also have to kind of interpret your results, right? Does that make sense? All right, so it was in the air, all right, for approximately 8 seconds. All right, now, what is the greatest height the rocket reaches? Well, the greatest height or the maximum height, right? So that would be, all right, that would be our vertex right here. All right, and so that also means we want to find the y value. But before we find the y value, we have to find the x value. So this is where we use that x equals negative b over 2a. So x equals the opposite of b divided by 2a. All right, so that's negative 128 divided by negative 32. So if I do that on my calculator, negative 128 divided by negative 32, that is exactly 4. Now remember, anytime we get our variable for x, to get our y value, we always just plug that back in. So now, right, so h equals negative 16, and then 4 squared plus 128 times 4 plus 3. And then once again, once we write it well, we should be able to just type that into our calculator just like it looks. So negative 16 times 4 squared plus 128 times 4 plus 3. And that tells me that it was at a height of 259. All right, so this says at 4 seconds, right, it reached a height of 259 units, feet, meters, whatever we happen to be for this particular particular problem. All right, now notice now, how high is the rocket after 2 seconds? All right, well, that tells me that the time is 2. Well, once again, that tells me what to plug in for. So the time is 2, so I'm going to plug in for t. And so this is really a lot like what we just did here, right? So, all right, height is negative 16. I'm going to plug in the 2 squared, and then plus 128 times 2, and then plus 3. All right, so labeling your variables, knowing what you're looking for will help you with the problem as well. So once again, let's just type all this in. Negative 16, 2 squared, plus 128 times 2, plus 3. All right, and it's 195. And I know, right, I'm not to my vertex yet, right? I know it's got to be less than 259, so 195, all right, makes sense. All right, how high is the rocket after 6 seconds? Same idea, right? I'm just going to plug in, right, 6 for t. Now, what I know is I've already crossed, all right, I've already crossed my vertex, right? So I know it's now on the downhill side, right? And so I know it should be less than 259. All right, so negative 16, 6 squared, plus 128 times 6, plus 3, and it's at 195. Let's think about that. Symmetry, right? Symmetry, right? We know that if we drew our axis of symmetry, all right, 2 seconds and 6 seconds, they're the same distance from that axis of symmetry. So hopefully this makes sense that you should get the same number here. All right, now find the exact value of the height of the rocket at 2 seconds, which we already did right here. So that's a bad question. All right, so we won't do that one because that's just a repeat. All right, so that takes care of problem 1. Now, so you can see that that's just one problem, right? All right, and it's already taken us about 7 or 8 minutes to get through. All right, so that's just the way these problems are, right? So it may take you 10 or 15 minutes to work through one particular problem, especially if we give you 4 or 5 parts to do so. So don't worry about that. All right, so now let's look at problem 2. All right, a little simpler equation here. All right, a ball is thrown in the air. The path of the ball is represented by the equation h equals negative t squared plus 8t, with h as the height in meters and t as the time in seconds. All right, so now what is the maximum height of the ball? So once again, anytime we see maximum or minimum, we know we are talking about the vertex. And then we have to determine, is that the x variable or the y variable? So what is the maximum height? So when I look, right, height is the y variable. So we're going to start with negative b over 2a. So x equals negative b, all right? So negative b, and then times 2a. So that's negative 8 divided by negative 2, which is 4. All right, so now I have to plug that in to find that maximum height. So negative, now that negative is on the outside, all right? And then I'm going to open my parentheses and do 4 squared, and then plus 8 times 4 like that. All right, and so let's just type that like it looks. Make sure you use the negative symbol right down here and not the minus symbol when you need the negative. Open parentheses, squared, plus 8 times 4. And that tells me it reached a maximum height, all right? And this time we know the units is meters, all right? So 16 meters. All right, so how long does it take for the ball to reach the ground? All right, so once again, the ground is at a height of 0. Okay, so now that means that 0 equals negative t squared plus 8t. Now, Once again, you get to choose the method of solving here. Notice how this only has two terms, and it's a little simpler than what we had up here. And if I see two terms, my first thought is, oh, can I find a GCF? All right. So notice if I look here, all right, what's the biggest number that goes into -1 and 8? That would be 1. And then how many t's do they have in common? 1 t. And so notice I can factor out a GCF very quickly here, and then I have -t plus 8, all right, in my parentheses. So sometimes factoring is faster, especially if you have two terms, you can find that GCF, because now, right, I have t equals 0, and then I have -t plus 8 equals 0, all right, which means what plus 8 is 0? That would be -8. So -t equals -8. And then this is -1 times something gives me -8, which means my time would be 8. So now, okay, so how long does it take for the ball to reach the ground? Well, it looks like it started on the ground, all right? Okay, so maybe somebody's laying on their back, throws it up, all right? But then it hits the ground after 8 seconds. So how long is it in the air? How long does it take for it to reach the ground? It takes 8 seconds. All right, so find the exact value of the height of the ball after 3 seconds. Well, once again, that tells me that t is 3, and I'm looking for h, so h equals negative, and then 3 squared plus 8 times 3. All right, so once again, write that down. All right, identify those variables, and it will help you. So negative, and then 3 squared plus 8 times 3, and so it's at a height of 15. So it's really close, right, to the vertex, right, that maximum height. And that makes sense because the vertex happened, that maximum height happened at 4 seconds, right? So if I'm at 3 seconds, I should be pretty close. Now, at what time, now notice this time we're looking for t, at what time does the height of 10 feet, so h is equal to 10 this time. So now I have to plug 10 in for h. So if I do that right here, I get 10 equals -t squared plus 8t. All right, now, once again, anytime we solve, it has to be equal to 0. So notice the first thing I need to do here is subtract 10 from both sides, and I get 0 equals -t squared plus 8t minus 10. All right, so now you might be tempted to factor this, all right? And you can go through these combinations pretty quick, and I'm going to go ahead and tell you, right, that there's not a combination, all right, to get to +10 that adds to be 8, because I have 1 and 10 and I have 2 and 5. So I can get to 7 or 11, right, but I can't get to 8. So what this means is we have to do, all right, the quadratic formula. All right, so I'm going to go ahead and just grab a sheet of paper here, all right, and do the quadratic formula on it, since we're just a little bit out of room right here. So if you guys want to do that on a scratch piece of paper, all right, I'll try to squeeze it in. So notice A is -1, B is 8, and C is -10. So now let's go through x equals the opposite of b, plus or minus the square root, b squared minus 4ac, all right, all over 2 times a. All right, so x equals -8 plus or minus the square root of, and let's just do everything inside that square root there. So 8 squared minus 4, -1, and -10. All right, so I get 24. All right, and then that's over -2. All right, so now once again, this is where we, all right, split these up. So we get -8 plus the square root of 24 over 2, and we get x equals -8 minus the square root of 24 over 2. And then we're going to put that into the calculator. So -8 plus the square root of 24, it equals, and then, all right, so notice it gives me an exact answer, no big deal, because now I'm going to divide this, I'm going to divide by 2 and put a decimal after it, and it'll give me that decimal answer. So -1.5 or 1.6, depending on how you want to round, okay? Now, -8 minus second square root of 24. All right, once again, give me that exact answer. We need a decimal answer, right? So now when I divide by 2, I'm just going to put a decimal after the 2, and it gives me, all right, oh, I left the negative off here. That's not good, so let's go back and do that again. All right, so very important. See how that changed my result? All right, so let's go back and do that again. So -8 plus the square root of 24, all right, and divide by -2, and that gives me a positive 1.5. All right, and then x equals, and then I get -8 minus the square root of 24, and I'm going to divide that, okay, by -2, and I get 6.5. All right, so notice my solutions here. So it asks, okay, so at what time does the ball reach a height of 10 feet? All right, and I'll kind of move this over. And notice we get two answers here. And that should make sense because if we think about the path of the ball, right, it goes up and it comes back down to the ground. And we know the maximum height, right, we said was 16. So that means it's got to hit 10 feet on the way up and 10 feet on the way down. All right, so getting two answers here, thinking about both of those, does it make sense? Yes, it's going to hit 10 before it gets to the vertex and then 10 after the vertex. So having a time, all right, of 1.5 and 6.5 seconds makes sense. All right, so hopefully that gives you a good feel for the types of problems we're going to work on. We'll do some more of these in class. If you have any questions, all right, bring those with you and I'll see you then.